Okay, now if you want to understand the ANOVA, you have to understand this example. Now I am saying that the performance of any person depends upon two things. One is the intelligence, or you can say IQ level, and second is the hard work. So there are the performance depends upon the two things, intelligence and the hard work. And intelligence can be divided into two categories. High intelligence. Suppose I am dividing into two categories: low intelligence, high intelligence, low intelligence. Hard work, for simplicity, I am dividing into two categories: the hard working, or high, and low hard working. So I am dividing the two groups in each. Okay, so basically there are two kind of people in both, and even the hard work and this, right? Now why I'm making the two groups, I just want to explain. If you apply the t-test, you can compare high and low independently. If you compare the hard work, low hard work and high hard work, you can apply independent sample t-test. So do you think the combination of interaction and hard work also play important? Intelligent in individually is very important. Hard work individually is very important. But is it possible that we will combine them? If we combine them, the two groups of intelligence and two group of hard work will come into different groups. Like I'm showing you the different groups, different possibilities of the interaction. Suppose I make an interaction of the intelligence and the hard work, how many subgroups I can make? Like for example, these subgroups I'm showing you: high intelligence, high hard work, high intelligence, low hard work, and low intelligence, high hard work, and low intelligence, low hard work. Now the respondents are divided into four categories. Now the respondents are divided into four categories, and basically we are applying the ANOVA in the among the four categories. So in two-way ANOVA, we are applying the ANOVA in the interaction of the two variables, and we can make different categories, and we are comparing the mean of these. Right. So in general, whenever two-way ANOVA comes to you, one thing which should comes in your mind is the interaction effect. So I'm writing here. There are two types of effects in two-way ANOVA. One is known as individual effect, and the second is called interaction effect. Right. So what is the meaning of individual effect and interaction effect? Individual effect means whether intelligence depends upon the performance. No, whether intelligence have a significant influence on the performance. This is individual effect of intelligence. Then I can find out whether the hard work is having significant effect on the performance. This is the individual effect of the hard work. Now when I say, can I say the interaction of the intelligence and the hard work have a significant effect on performance? This is called interaction effect. So in the interaction effect, basically what we are doing, we are comparing the mean of the interaction subgroups. So now I just want to know whether you understand it or not. So if this point is clear, then it is very good. Okay. Now I'm giving you one more example. Okay. Because if you do not understand this example, no example will be clear. So that's why I'm asking whether it is clear or not. So now I'm going to explain once more. Suppose I am having the variable called happiness. Happiness score. So happiness score. And I want to know, can I say the happiness of male and the happiness of female are same or different? The variable is gender. The grouping variable is gender. and gender have two categories, male and female. Now I want to know whether happiness score is different for male and female. So in this case, I will go for t-test because there are two groups. Now I am taking one more example, income. So I divide the income into three categories: low income group, middle income group, and upper income group. Right. So if I want to know, can I say the happiness score of the low income group, high income group, middle income group are equal? Maybe, may not be. Maybe, may not be. So if I'm interested in finding out the impact of only income, then which test is applicable? One-way ANOVA. Now the question is that now I want to know that, can I say the male of the middle income group is having the different happiness score of the female of low income group? Now what I'm doing, I'm comparing the interaction of the gender and income. So if I multiply gender with the income, how many group I can make? Like I'm showing you male low income group, male middle group, male upper group. So this is the interaction of the male and the income. Now similarly, I can make the interaction of the female and income, like female low income group, female middle income group, and female is upper income group. So how many groups are now I'm having after the interaction effect? 6 groups. Now what is my purpose? My purpose is that, can I say all these groups have the same happiness score? Can all these groups have the same happiness score? And now simple question I'm asking is that, how the groups formed, how these 6 groups formed? By interaction of the gender and the income. And when I want to see whether all the subgroups are having the same happiness score, this concept is called interaction effect. So I'm saying that whenever I want to find out the effect of gender on happiness, this is called individual effect. When I interested to find out the effect of income on the happiness score, this is called individual effect. When I want to see the effect of the interaction, so this is called interaction effect. So this interaction effect is the purpose of applying two-way ANOVA. Now tell me one thing, is it clear or not, so that I can go to the data? And now can I go to the data? And so I hope you understand what is the interaction effect. And frankly speaking, if you're not understanding this, so it is not possible to understand two-way ANOVA or MANOVA and all. So you should be clear on this topic, on this aspect. And I'm telling you that nobody can explain you like this clarity. Okay, now I'm moving to the example so that I can show you the practical example of two-way ANOVA. So let me show you the data set. And so first of all, we should click on two-way ANOVA, happiness. In this example, this is the happiness score, and this is the happiness score, and we are having different, like we are having the education level, we are having the different respondent of different education level, marital status, and male and female, income level, or where they lives, and the occupation of the different, and the happiness score. Now the condition of applying two-way ANOVA is, one, you must have the one scale variable, and in this data set we are having scale variable in the form of happiness score. So happiness score is the dependent variable here, and happiness depends upon. So let's take two combination. So first of all, I'm taking the combination of male and female, sorry, gender and the income group. So I'm taking the combination of gender and the income group. So just see the commands. Analyze, GLM model, general linear model, and univariate. Univariate we use for the two-way ANOVA, multivariate we use for the MANOVA. Now I'm applying the univariate, and in univariate, the happiness score is my dependent variable. It is a scale variable, and I'm taking the gender and the income in the fixed factors. Actually, the software call the nominal variables as the factors. So I will put all the variables in the factor variables. Factor means category. And first of all, I want to go to the models, plots. So because in 2 ANOVA these plots are very important. So gender I will put in the horizontal, and income I will put on the separate lines. If I think, so basically it is much better if I put gender into the separate lines, and income I should put on the horizontal lines. So I will tell you the reason why. And then you add it, you will make an interaction effect. If you add it, you can make an interaction effect. Okay, continue. And then go to the options. In options, we want the homogeneity test, and we want the descriptive analysis, and that's it. After that, you can click on the post hoc. If in any group you are having 3 categories, you can apply the post hoc test also. In gender, we cannot apply post hoc because there are only 2 groups. In income, we can apply post hoc test. So this post hoc test is Tukey test, and it will compare the mean of the different groups. Continue. So after these commands, now I'm going to click OK, and I will show you the result. Now see the result very carefully. And I have applied two-way ANOVA in many research projects, so there is not a problem of clarity. The first table will indicate that how many data you are having. Like we are having the 382 observations for male, 274 observations for female, and less than 10 lakhs is 121. It is an income group, and 10 to 25 lakhs is the 280. There are 280 respondents in this group. There are 255 respondents in the third group. Fine. Now descriptive is actually, because you know that I make 6 groups. So here I'm comparing the mean of the 6 groups. Like for example, I'm just showing you. This is the interaction of the gender and the income level. So it is an interaction table. The mean of first group is this, second group is this, third group is this, and so on. So these are the different means of the different groups, right? So, but actually by looking just at this table, we cannot interpret anything. We have to see the interpret in next tables. Okay, the Levine test is only the assumption test. So this table is showing you the assumption whether the groups have equal variance or not. So I'm just right here. So how we interpret Levine test. Assumption, we are examining the assumption that the variance of group number 1 is equal to the variance of group number 2 is equal to the variance of the group number 3. Right. So this is the assumption of the parametric test. Can we say all the groups have the equal means? So you have to check based on the mean, and p-value of this should be equal to more than 0.05. So this value is more than 0.05. So assumption fulfilled. So the assumption fulfilled. Right. So this is the purpose of Levine test of equality, and we want to fulfill this assumption. And if the assumption is not fulfilled, then there is a problem. So we want that assumption should be fulfilled. Now let's move to the next. The next table is the most important table in two-way ANOVA. And believe me, if you are writing a paper, if you will write a paper on the two-way ANOVA, this table is the table which must go to the research paper. So this table is the most important table, and I'm showing you how to interpret this table. Now in this table, I want to find out whether the individual effects are significant. No, so my first objective is that whether the individual effects are significant. Question number 1. Question number 2, whether the interaction effect is significant. So we have to find out the answer of these 2 questions. Okay, let's see. Gender, significant. Income, significant. Interaction, significant. So the answer is that the individual effects are significant, and the interaction effect is also significant. So it means the two-way ANOVA is highly significant for this data set. So the interpretation of this result is that gender and income not only influencing the happiness individually, but also have a significant effect on the happiness. The interaction effect of the gender and happiness is also significant on the happiness score. So ना केवल वो individual effect दिखाते हैं, बल्कि interaction effect भी है. So not only individual effect is significant, but also interaction effect is significant. So this is the most important conclusion from this result, and this result of 2 ANOVA is the most important table. Okay, now let's move. After that, we go to the post-hoc test. In post-hoc test, this table you cannot is not important. So this table you have to find out. So we can say here, if you see this table, the mean of more than 25 lakhs is the highest, and the mean of 10 lakhs is close to it, and the mean of 10 to 25 lakhs is the minimum. So it means the happiness score of the different respondent from different income group are different. Now, after that, I want to see this interaction effect, which is the most important plot. So if you ask me that what should go to the research paper or a thesis, so I would like to send 2 or 3 tables in the thesis or the paper. One is the 100% chance is the graph. The graph is the most important part of the 2 ANOVA, and the table where I show you the individual effect and the interaction effect. So these 2 things are most important, and other things are as per your wish. If you want, you can report, otherwise not. So 2 things are very, very important of 2 ANOVA. One is the interaction effect and individual effect, and this is the effect. Now, what is the effect? Effect is that the female, which are indicated by the red lines, the female in the income group of less than 10 lakhs are very happy. The income of the female of the income group 10 to 25 lakhs are very sad, not very happy. And the females of the income group more than 25 lakhs are again very happy. So the happiness of the females decreasing first and then increasing first, then increasing. And after that, if you see the male as the income level increases, the happiness of the male also increases, right? The interpretation is very simple. In case of female, the happiness is highest when the income when the income is more than 25 lakhs or less than 10 lakhs. But income of female is the happiness score is less in middle group. So this is the interaction of the gender and the income. Now I will show you one more example so that you can understand what is the purpose of 2 ANOVA. I hope this example is clear to you. It's not a very difficult. If the concept is clear, then the results are very easy. So I'm taking one more example. Let me take the income and marital status. So let's say let's see the marital status and the income. Okay, then go to analyze, GLM, univariate, and now I'm going to happiness is my dependent variable. Now I'm removing the gender and this. I'm taking the marital status, and let me take the marital status and education. Let's say. So here I'm combining the marital status and the education, because in 2 ANOVA you can take only 2 variables. Now let's all the commands are already there, so I did not give any special command. Now first of all, I want to see whether my effect is significant. The assumption is fulfilled. Live-in test is showing you that assumption is fulfilled. Not a problem. Okay. And the test of I forget to give one command, that is the plots, because they are very important. Plot. So in plot, now I want marital status in the separate lines. Yeah. Education is my horizontal line. Add. This is very important. And post-hoc, because education have 3 categories, so I am taking education for the post-hoc test. And I think all other things are clear. Okay. Now let's see the results. The assumption is fulfilled, not a problem. And yeah, the first thing which I want to see, whether the marital status is having individual effect. Yes, p value is significant. Can I say education is having the significant effect? Yes, it is there. And can I say the impact of marital status and education is significant? Yes, it is significant. All the p values are significant here. And what is the effect? Let's see. So here we found that the blue lines is for single. So if the blue line single graduate, so those who are single and those who are graduate are more happy as compared to single postgraduate. So those who did the graduation and single are more happy as compared to the postgraduates, those who are single and postgraduates. Similarly, married obviously, if the education is low, they are not very happy. If education is high, then they are happy. So married postgraduates are happier than married, unmarried graduates. Similarly, we can say that the single graduates are more happy as compared to the single postgraduate. So this is the interpretation of the two-way ANOVA. I hope that two-way ANOVA is clear now. Now I'm going to the MANOVA part. And second example is the second technique which we are going to discuss.